We also used this test to validate our numerical and analytical models. So what you have in terms of the blade design or rotor characteristics is very similar to what you would use for wind turbine. So you plot your power coefficient Cp versus the tip speed ratio and your thrust coefficient versus the tip speed ratio. And the black line that you can see here is measured data from our Frankfurt Loch testing of the full-scale device. The red line is an analytical blade element momentum tool to predict the turbine performance. The blue dots are 3D CFD open foam simulations. And last but not least, the pink symbols here are model scale test results out of a towing tank test in Germany. So there's a rather good agreement, and we are quite happy with that. It's actually a better agreement in terms of power than in terms of thrust, which is a little bit surprising, but we are quite happy with the validation of our design tools. When it comes to the possibility of deploying those machines, I mentioned that before. It's very flexible, basically. You can also deploy this machine, of course, in a river without a dam. We are looking into what we would call community scale solutions, so up to 200 kW, to replace, for example, diesel generators in isolated islands which are dependent on diesel for their electricity consumption, with very high costs of energy, up to 80 to 90 cents per kilowatt hour, but also for very big installations in the order of 2 to 3 megawatt per platform. So the real advantage of these small and modular turbines is really that they are very cost effective, and you can deploy them with various numbers of platforms, mainly floating platforms, which allow for easy maintenance, access. You could also use, for example, existing infrastructure in terms of bridges, and go for various types of installations. Some examples and projects where we're working towards at the moment. We sold 2 of these machines to a small company called Sustainable Marine Energy out of the south of England. They are developing a submerged platform that you can see here with 2 of our turbines mounted on this device. They're currently doing testing just with the platform to train marine operations and test the deployment procedures. And we'll very soon do some power tests with the turbines, and we're looking forward to these results as well, of course. Another project that we're working towards is a cooperation with a Dutch consortium, which is led by Blue Water. Blue Water is developing a small floating system, mainly for remote communities, in the order of 100 to 200 kilowatts. And we're testing there. We will test the turbine in Dutch waters this summer. And we're not the only turbine supplier which is working in this consortium, but there's also another small turbine supplier called Tocado, and they will test their turbine at this platform as well. There are another very interesting projects, mainly in the Netherlands, where they would like to open dams, for example, and then use these sluice gates to install turbines into existing infrastructure. And if you then do the levelized cost of energy calculations, then you can come up with very low costs, up to 10 cents per kilowatt hour, because you use the existing infrastructure. So that's already a very competitive price in terms of cost of energy. let me use the last minutes to give you an overview on our own platform system. We call that a Triton platform. And a Triton platform basically consists of a number of things. So it is a semi-submerged floating platform, which is, you can see it here, penetrating the surface, so it's surface piercing. And it basically can flip between the operating and the maintenance position. What you can see here is the operating position. You have a number of turbines mounted to these horizontal cross arms. We have all the power electrics in these bar buoys. Within these bar buoys there are also water ballast tanks. So if you deballast the whole system, it basically floats up to the water surface as a catamaran, and then you have even access to the turbines in situ. It is connected to seabed foundation, whatever kind of foundation, if it's a monopile or a gravity base with these tether arms. And we have a 3 degree of freedom bearing or subsea hinge here at the bottom with a slip ring to get the electric power out to the subsea cable. And the whole device is passively yawing around this point to basically rotate itself into the flow. These are just some more artist impressions on the maintenance position and the electric cabinets within the bar buoys. If you look at these Triton platforms, of course it's quite new technology. However, it's just a new arrangement of different proven technologies. So it's a steel construction, which is it's basically a vessel. So that's common shipbuilding practice. Water ballast tanks are also, of course, widely used in the shipbuilding environment. And there's also a ship called the Flip, which is operated by the US Navy, which basically uses ballast water to flip from the operating into the maintenance position. If you look at the seabed hinge, that's of course a critical point of the whole system. However, if you look into the loading of this seabed hinge, then it's very, very similar to highly loaded rudder bearings. And if you look into the slip ring, for example, that's also common practice for the offshore oil and gas industry. So I mean, this platform has never been built before in full scale. There had been a number of model scale testing to test seakeeping and so on, as well as simulations. But the next step really is to demonstrate the device in full scale. Therefore, we founded a company called BlackRock Tidal Power in Canada. In Canada, there's also a test center for tidal energy called FORCE, Fundy Ocean Research Center for Energy. And FORCE is basically here in this passage, which is called the Minus Passage. There are 4 berths available, or which are already occupied, and one of the berths belongs to Shuttle Hydro / BlackRock Tidal Power. The sea cable is already in place, there's a feed-in tariff in place, and we're working towards the deployment of the system that you can see here. So that's a 2.5 megawatt installation using a Triton platform with 36 shuttle turbines. We are currently going through detailed design, also doing some more measurements on site, and planning to install the whole thing end of 2016, beginning of 2017. The basic idea of this platform demonstration is not only to demonstrate the technology, but also to demonstrate that we can really, using this different approach of technology, that we can bring costs down and make it commercially viable already in the first demonstration phase. Thanks a lot.
Thanks, Herr Stallman, for your conference and your explanation. Como todas las conferencias, ¿alguna duda, pregunta, algún ruego, alguna cuestión que queráis sacar? Thanks a lot. Bien, señores, nos hemos incluso adelantado media hora al tiempo previsto. Las conferencias como tal acaban de finalizar. Les agradezco a todos muchísimo su asistencia. Por supuesto, la línea de nuestra empresa, nuestra revista Rotación y la empresa va en seguir organizando conferencias cuando haya algún evento importante dentro del sector. Y por supuesto también tendrán conocimiento todos ustedes e invitación por si quieren estar con nosotros en esas futuras conferencias como han estado hoy. Muchísimas gracias a todos de nuevo. Ahora les darán una bolsita a la salida con unos pequeños obsequios. Gracias de nuevo y que pasen un buen día. Gracias.